Okay, I'm going to solve part A of this hot air balloon problem. So we have a hot air balloon rising straight up from the surface of the Earth. And so part A asks us to find the magnitude of the average velocity. So average velocity, let's just write down a formula for that. So we know if they're asking about average velocity, you're going to need the formula for average velocity. Okay, so average velocity is displacement divided by time. Now, this is a little bit different from the formula for average speed. Remember, average speed is just the total distance traveled divided by the time. So average velocity is a vector and displacement is a vector. We're looking for the magnitude of the average velocity, meaning that we're going to look for just the length or the number, not the direction. So let's try calculating and then you'll see how that works. So we know that the average velocity, if I use a little bar to denote average, is delta x over delta t, and that represents displacement, because remember, displacement is just dependent upon your initial position and your final position. So that delta x really means your final position minus your initial position, which is what displacement is. It doesn't depend on anything in between. It just matters where you start and where you end. And then the change in time, well, that's the final time minus the initial time. Now, we normally just start the clock at 0, and that's not really a problem, but I'll write it out just this one time so you can see how that works. Okay. So what is the magnitude of the average velocity of the balloon for the first 2.20 seconds of its motion? Okay, well, where did it end up after that 2.20 seconds? So it says at 2.20 seconds after its launch, the balloon is 50 meters above the ground. Okay, so 50 meters must be the final position. And since it started on the ground, it started at 0 meters. And then the final time, well, this is 2.20 seconds. And the initial time, like I said, we'll start the clock at 0 seconds. Okay, so now we have 50 divided by 2.20, and when you do this on the calculator, you end up getting 22.7 meters per second. And since I'm looking for the magnitude of the average velocity, I do not need to include a direction with the answer.